between a layer 2 MPLS VPN and a layer 3 MPLS VPN? Well, simple.
Device it runs on.
Not the device it runs on, how it appears to the customer. Remember, MPLS does not run in the customer's network. MPLS runs in the cloud. You're not running MPLS on your devices. There's never really an instance where you're actually running MPLS within your enterprise. MPLS, which stands for Multi-Protocol Label Switching, is a protocol that runs in the cloud. Whether it's a layer 2 MPLS VPN or a layer 3 MPLS VPN means, does the cloud look like a switch or does the cloud look like a hop? All right? So in the case of a layer 2 MPLS VPN, the customer router on the left and the customer router on the right, they look like they're directly connected to each other. Whereas in a layer 3 MPLS VPN solution, the cloud actually is present and it participates in the routing for the customer. Layer 3 MPLS VPNs are typically used when you're subscribing to managed services like voice over IP, internet or firewall communication, whatever it might be. All right. When I say internet and firewall communication, like a hosted firewall solution, a hosted voice over IP solution or whatnot. Now, if you want to learn all about MPLS, you have to take the service provider courses. Believe it or not, MPLS is not even covered in the CCNP. It is a topic that is heavily covered in service provider, the service provider classes. What is GRE? GRE is a tunneling protocol that allows me to encapsulate. GRE allows me to encapsulate routing traffic over a over a public domain. So let's say I'm running EIGRP on the router on the left, and I'm running EIGRP on the router on the right. But my service provider is not running EIGRP. So there's no way for my service provider to assist me in exchanging routing information. What I do is I set up a GRE tunnel between the router on the left and the router on the right using a tunnel interface. And I take all of that EIGRP traffic and I tunnel it through the transport network so that the router on the left and the router on the right can become peers over an internet connection. Now, GRE is not an encryption protocol. So this tunnel traffic is not hidden from the internet. So oftentimes you'll see GRE configured on top of IPsec to provide a security feature as well. I think what I might eventually do for this course is I'm going to thin out maybe some of the other material and I'm going to add in some configuration examples for GRE. But for now, and certainly for what the test requires at this point, you don't really need to know how GRE is configured, you just need to know what it does in general. All right? A lot of these concepts are kind of high level right now. DMVPN, Dynamic Multipoint Virtual Private Network. Okay? Now what this does is it allows me to interconnect locations over a public domain. You've got to think that we are interconnecting the hub router and the spoke routers over a kind of just a broadband internet access. Right? This is not an MPLS network. This is not a frame relay network. These are hub and spoke locations that are interconnected with just standard internet connections. So the hub might have a high-speed internet connection to the internet, and each of the spoke routers might have some sort of business class broadband connection to the internet. And we want to set up a virtual private network between those locations. You would not use DMVPN if you had some sort of other VPN technology like MPLS or frame relay or IPsec VPNs. All right? Now, DMVPN is Cisco proprietary, so you can only run it on Cisco platforms. That's another downside to this DMVPN technology. It's a very simple process. You set up the DMVPN configuration on the hub, and then each of the spoke routers go back and communicate their information to the hub. They essentially register to the hub. Your IPsec tunnels get created. You encapsulate your routing protocols inside of GRE. And now all these routers are interconnected securely using those technologies. There's another major component to DMVPN called NHRP. We'll see what NHRP does in the next couple of slides.
Why is the hub being used? I didn't think anyone ever used hub.
Well, when they say hub, they're not talking about actually a hub. They're talking about a hub and spoke environment. Hub is the center.
A bus company where 30 buses come in, that's the hub, but where one bus stops, that's just a bus stop?
Spoke. Yeah.
Spoke.
Okay.
I always think of a bicycle wheel, right? The hub is the center of the wheel, and the spokes go out to all the external destinations. Now again, I want to make it clear what the benefit of DMVPN is. It allows us to establish this virtual private network over public broadband internet, or just standard internet access. All right? So the first thing that happens is we set up these things called hub and spoke tunnels. Those tunnels are automatically registered through the configuration, and each spoke destination is going to register itself to the hub. And on top of that, each spoke destination is going to identify what networks exist behind them to the hub. So essentially we're building this routing architecture where we can identify reachability information. And that's where the NHRP protocol comes into play. We'll see that in a couple of slides here. The hub and spoke tunnels are permanent. That's the first step to establishing this DMVPN architecture, is you set up these permanent hub and spoke tunnels. The spoke-to-spoke tunnels are temporary. Right? Now think about it. The router on the left, the bottom left, wants to send the packet to the spoke site on the right. They could send the traffic through the hub, but they're all connected to the internet. So why not set up a temporary method of communicating from spoke to spoke? And that's where multipoint GRE comes into play. It's called multipoint GRE because I'm actually establishing multiple tunnels. I'm actually establishing multiple tunnels. Now let's talk about NHRP, because without NHRP, none of this works. The next hop, resolution protocol. NHRP provides a mechanism to dynamically learn the IP address of the spokes. The hub is the NHRP server, and the spokes are the NHRP clients. There's a database that gets built in the hub of all of the physical and tunnel addresses of the spokes. Now, what is different between a physical address and a tunnel address? Any ideas? What do they mean by the physical address of the spoke?
IP address.
It's the actual IP address of the router interface that connects to the internet. A tunnel interface is a virtual address. It actually gets tied to an interface called a tunnel interface. So there's a pairing that says, okay, if you want to get to this tunnel interface, then you need to go to this physical address. So what happens is the spoke routers have a very minimal configuration. They essentially have a basic configuration that says, hey, when you boot up, you need to go contact this NHRP server and register your information to that NHRP server. And then the NHRP server starts building this database of reachability information. Now you have to understand what else is happening here, guys. Two things are happening. A IPsec tunnel is being created, and a GRE tunnel is being created. The purpose of the GRE tunnel is so that if we're running a routing protocol like EIGRP or OSPF, those spoke routers can now form peering relationships with the hub router. So they can actually share routing information. Remember, what's behind these spoke routers? Subnets. Ultimately, those subnets have to be advertised. Otherwise, what's the point? Right? Now, what if one spoke needs to send traffic to another spoke? Traditionally, what would have to happen is all of that traffic would have to go through the hub and then be sent back down from the hub to the other spoke. But with new multipoint GRE, that's not necessary. We use NHRP to create dynamic tunnels from spoke to spoke. So let's say the spoke on the left, down here where they have the little yellow dot, wants to go to the spoke to the right of it. Okay? And it wants to send a packet to 10113. By the way, 10113 would be the tunnel interface on the other spoke router. All right? Whereas 209.165 is the real IP, the public IP. And the tunnel interface is actually what is used as the next hop address for all of the routes that are learned by that spoke. Here's what's happening, guys. Let's say, I know it's hard to visualize. Let's say this guy has a tunnel interface and he's got a physical interface. This tunnel interface is 10.1.1.3. Now behind the router, I have a bunch of networks. Okay, private networks. When this router boots up, it sends an NHRP message to the hub and it registers to the hub. A tunnel gets created between this router and the hub, which then allows these routes, network X, network Y, and network Z, to be advertised to the hub with a next hop of the tunnel interface, not the physical interface. Follow what I'm saying? So this server is building a database of all of the peers, but at the same time, I have an EIGRP topology table that has all of the networks that are listed. It's like a regular routing. I mean, think about it. It's like if I took a cable and literally plugged a cable in from here to here. There's a bunch of networks behind here. They're going to get advertised to this router over that cable. The only difference is there's no cable, there's just a virtual link. Now, because all of these routers are running EIGRP and they're all peered together, this EIGRP information is being shared to everybody. You guys follow me? So this router knows, hey, if I want to get to network X, I need to send the packet to 10.1.1.3. But it's programmed to say, hey, if I want to send packets to 10.1.1.3, let me go ahead and query the hub so that the hub can tell me what the public IP is of that router. And I will set up a temporary tunnel from my public IP to this public IP so that I can route that traffic directly back and forth between those routers. This is why it's called dynamic multipoint VPN. Because there are these dynamic tunnels that are being created whenever I want to communicate from one spoke router to another. Follow? If you're interested in DMVPN, which by the way is not one of the most popular forms of VPN that exists today, although a lot of people do use it. There are plenty of videos on YouTube that talk about DMVPN and actually give you configuration examples and so on. The goal in this class, of course, is just to expose you to the general concepts. All right. Now, as far as IPsec goes, I think pretty much here everybody is familiar with what IPsec is. That's traditional VPN, where you're setting up site-to-site tunnels using cryptography, right? You've got an authentication component. You've got a confidentiality component where you're actually encrypting data. You've got a data integrity component, like a hashing algorithm that allows you to verify whether or not messages being sent and received have been modified in transit. So IPsec is actually incorporated into DMVPN for the purpose of encrypting the data that goes across the public domain. We don't really talk about any IPsec in this class because all the IPsec stuff is reserved for the security course. All right. All right.